You've probably seen those mind-blowing AI-generated images floating around online, and you're wondering, how does a computer actually create an image from words? Well, I'm about to break down the weirdest, coolest part of modern AI in a way that actually makes sense. So here's the thing. When you type something like a cat wearing sunglasses on a surfboard into something like dall-e or Midjourney, the AI doesn't just have a database of pre-made images it's flipping through. It's not searching Google Images. It's actually generating a completely new image from scratch, pixel by pixel, based on patterns it learned from billions of images. And honestly, the way it does this is kind of mind-bending. Let me start with the foundation, machine learning. You've probably heard that term thrown around, but here's what it actually means in this context. Imagine I showed you 1,000 pictures of dogs and 1,000 pictures of cats. After a while, you develop an intuition for what makes something look like a dog versus a cat, right? The shape of the ears, the way they move, the texture of the fur. You wouldn't be able to perfectly articulate all the rules, but you'd know it when you saw it. AI image generators learn the exact same way, except they learn from way more examples, and they do it mathematically. During training, these models look at millions and millions of images paired with text descriptions. A photo of a sunset paired with the words golden hour over the ocean. A painting paired with impressionist-style landscape. A screenshot of a person coding paired with programmer at desk. The AI is basically absorbing the statistical relationship between words and visual patterns. But here's where it gets really interesting. The AI doesn't just memorize these images. If it did, it would just be a search engine, right? Instead, it learns the underlying patterns. It figures out that certain word combinations tend to produce certain visual features. Sunset correlates with warm colors and a low sun position. Impressionist correlates with loose brushstrokes and soft edges. Glowing correlates with bright spots and halos of light. Now, the actual architecture that does this learning is called a diffusion model, and this is the really clever bit. A diffusion model works backwards from noise. Stick with me here because this is genuinely fascinating. Imagine you have a crystal clear photograph. Now imagine slowly, gradually adding static and grain and noise to it until it becomes completely unrecognizable. Just pure white noise, like TV static. That process of adding noise is called diffusion. The model learns to reverse this process. It learns to take noise and gradually denoise it, removing that static, and in the process, it creates an image. But here's the magic part. The model is conditioned on your text prompt. So when you say, a cat wearing sunglasses, the model uses that information to guide the denoising process in a specific direction. Instead of denoising randomly, it denoises in a way that's consistent with the concept of a cat, the visual properties of sunglasses, and how those things typically go together. It's like the difference between just looking at random noise versus looking at random noise while someone whispers a description in your ear. The description doesn't create the image directly, but it guides your brain in interpreting what you see. The process actually happens in steps. The AI doesn't go from pure noise to perfect image in one shot. It's iterative. It removes a little bit of noise, checks its work, removes more noise, checks again. It might take dozens or even hundreds of these steps. And at each step, it's asking itself, does this look like it's moving toward a cat wearing sunglasses? If not, it adjusts. Now, you might be wondering, where do the actual details come from? Like, how does it know what sunglasses look like, or how fur reflects light, or how shadows fall on a cat's face? That's all baked into the patterns it learned during training. It's not like the model has explicit rules. It learned these visual patterns statistically from all those millions of images. This is also why image generation can sometimes fail in interesting ways. If you ask for something really unusual or a combination of concepts that didn't appear much in the training data, the model might struggle. It's trying to interpolate between patterns it's seen, and sometimes that interpolation gets weird. That's why you sometimes get AI images with hands that look like melted wax or teeth that don't quite make sense. The model learned what teeth look like in isolation, and it learned what weird proportions look like, but the combination is harder. Here's another layer. The text part of the process is also learned. The model doesn't understand English the way you do. It converts your text into something called embeddings, which are basically mathematical representations of what those words mean in the context of images. So when you type cat, it's not actually processing the letters CAT. It's converting that into a vector, a point in multidimensional space that represents all the visual patterns associated with cats. This is also why image generators sometimes interpret prompts in unexpected ways. If you say a red car driving down a blue street, the model is translating that into mathematical representations and then trying to generate an image that satisfies all those constraints simultaneously. Usually it works great, but sometimes the model gets confused about what's modifying what. The other thing that's important to understand is that different image generators use different architectures and training data. dall-e, Midjourney, Stable Diffusion. They're all based on similar underlying principles, but they've been trained on different datasets, fine-tuned differently, and they use slightly different techniques. That's why they produce different styles and have different strengths and weaknesses. Some are trained on more artistic images, so they lean toward a more painterly aesthetic. Some are trained on more photographic images, so they're better at photorealism. Some have been fine-tuned to avoid generating certain things. All of that is baked into the training process. And here's something that's worth understanding. These models are actually learning something real about how the visual world works. When a model learns that sunglasses have reflections and that reflections are usually on the lenses, it's not just memorizing that fact. It's learning a pattern about how light and materials interact. It's learning geometry, physics, aesthetics, all implicitly, through seeing millions of examples. That's why these models can do things like style transfer. You can say, paint this in the style of Van Gogh, and it actually works, even if the exact combination of sunglasses in Van Gogh's style wasn't in the training data. The model understands Van Gogh's style well enough to apply it to new subjects. The quality of what you get also depends a lot on your prompt. More specific, detailed prompts generally work better than vague ones. A serene forest at dawn with mist rising from a stream, soft golden light filtering through pine trees, photorealistic, highly detailed, is going to get you better results than forest. That's because detailed prompts give the model more guidance during the generation process. So to sum this up, image generation works by learning statistical relationships between text and images from massive amounts of training data, then using a diffusion process, gradually removing noise while being guided by your text prompt to create a new image. It's not magic, but it's definitely one of the coolest applications of machine learning we've got right now. If you want to understand how AI actually works under the hood, this stuff matters. These techniques are going to keep getting better, and understanding the fundamentals helps you think critically about what AI can and can't do. If you found this explanation helpful, please hit that subscribe button. I break down AI and tech concepts like this all the time, and I'd love to have you along for the ride.